An event planner is planning a party. It costs the event planner a one-time fee of $35 to rent the venue and $10.25 per attendee. The event planner has a budget of $200. What's the greatest number of attendees possible without exceeding the budget? The budget is $200. We're setting up an inequality, and 200 is the maximum value, but it can be 200, so we have greater than or equal to. And then the venue costs $35 to rent, plus an unknown number of attendees is $10.25 for each person. So we need to solve this two-step inequality. First, you subtract 35 from both sides, and then you divide both sides by $10.25. And you find x is approximately 16.09. It's actually 0.97, but regardless, you can't have partial people, so the answer is 16 people. If the absolute value of 4x minus 4 equals 112, what is the positive value of x minus 1? This is solved by making the 4x minus 4 equal to positive 112 and negative 112 in two separate equations. In both cases, we add 4 to both sides, and then we divide both sides by 4. Now we have the two resulting x values that would make the absolute value equation correct. But what they're asking is what is the positive value of x minus 1? I'm going to substitute 29 for x on the left, which gives me 28. And then I'm going to substitute minus 27 for x on the right, which gives me minus 28. And since they're looking for the positive value is 28. A cube has an edge length of 68 inches. A solid sphere with a radius of 34 inches is inside the cube, such that the sphere touches the center of each face of the cube. To the nearest cubic inch, what is the volume of the space in the cube not taken up by the sphere? This question is asking you to find the volume of the cube, the volume of the sphere, and subtracting them to find out what part of the inside of the cube is not taken up by the sphere. So to set this up, we'll find the volume of both. So we'll start with the cube. And then in the formula for base height and depth, we will substitute 68 inches for each. And then once we multiply, 68 cubed is 314,432. Now we'll find the volume of the sphere, which is 4/3 pi r cubed, and the radius is half the length of one of the edges to get to the center. So that would be 34, so we substitute that. Then we'll do 34 cubed, and we get 39,304. And now we'll multiply straight across over here on the calculator. So I have 4/3, which is 1.3333 times pi times 39,304. And I get 164,636. And I need to subtract that from 314,432. And the difference between them is about 149,800, which is choice A. What is the diameter of a circle in the xy plane with the equation x minus 5 squared plus y minus 3 squared equals 16? Well, regardless of where the center of the circle is over here, the basic equation of a circle is x squared plus y squared equals r squared. Well, if I was to take the square root of both sides, taking the square root of 16 gives me 4, so the diameter 8. Correct choice is B. For the exponential function f, the value f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? So first we need to find f of 1. So first we list the equation in A. Then we substitute for f of 1. And then we have 50 times 1.6 squared gives us 128. The second equation, f of 1 is 80 times 1.6 to the first power, is 128. For C, f of 1 is going to give us 128 times 1.6 to the 0 power. Anything to the 0 power is 1, so that's 128 times 1. And then for this last one, when you calculate f of 1, this is going to be 1.6 to the minus 1, which is the same as 204.8 over 1.6, which simplifies to be 128. Now, the reason we took the long way out, since each case here, f of 1 equals 128, what they were asking was, which of them represents, since k is f of 1, so here k equals 128 in each case. What they're asking is, in which one of these was k the base of the exponential function? And if you look over here, this was the base of the exponential function, so it was choice C. A model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. The model estimates that at the end of 2016, 1 year, there were 180 squirrels in the population. Which of the following equations represents this model where n is the estimated number of squirrels in the population t years at the end of 2015 and t is less than or equal to 5? Since it's 5 years, this has to be less than or equal to 5. Now here's the thing. If it's 150% more and I need to include the starting value, then this one here can't be correct because it wouldn't be multiplied by 1.5. Just to illustrate, if I start with $5 and I want to get 150% more than this, I would multiply by 250% or 2.5 because 1 is the original amount and the 1.5 is the 150%. So I need a 2.5. So over here, this is 2.5, this one's 2.5, so C can't be correct either. Now looking at the remaining two choices, since it tells me that after 1 year I have 180 squirrels, I can't start with 180 and then multiply it by something which is bigger than 1, because then the number of squirrels would be greater than 180. So this can't be true either. And I'm just going to plug the numbers in here. N is 180. And then I have 72 times 2.5, and it's been only 1 year. And then I'm going to have 72 times 2.5, which is 180. So the correct answer is choice B. In the given pair of equations, A and B are constants. The graph of this pair of equations in the xy plane is a pair of perpendicular lines. Which of the following pairs of equations also represents a pair of perpendicular lines? The first thing that I need to recall about perpendicular lines is that their slopes are negative reciprocals. Looking first at the first pair that we're given, I solve each for y equals mx plus b form. So I subtract 5x from both sides, and then I divide both sides by 7. And I see the slope of the first one is minus 5 over 7. Moving on to the second equation, I subtract ax from both sides. And then I divide both sides by b. And I see the slope of the second one is minus a over b. So since the slope of the second one must be 7 over 5, the negative reciprocal, then a must be minus 7. I'll write it in over here. And b must be 5. So look at what happened here to see a pattern. The a and b switched here and the b became negative, and a switched to being the b on the second one. So now, for the sake of going faster, we'll test b. So for this one here, looking at 10x plus 7y, when the 10x goes to the other side, I'm going to get minus 10 on top, and I'm going to get 7 on the bottom when I divide both sides by 7. So the slope should turn out to be positive 7 over 10. Let's look at the second equation. So to solve this for the slope, I subtract ax from both sides. Then I divide both sides by 2b. And I see the slope is, and I'll rewrite it a different way. So this time, in order to have minus a over 2b, I'm going to find what the a and the b are on the second one. Well, if this was positive 7, then this a is minus 7. And over here, the 2b has to be equal to 10. So in order to get 2b to equal 10, it would be 2 times 5. So I'll substitute my new a and b in here. And then multiplying straight across, I get minus times a minus is a positive. I get 1 times 7, and then 2 times 5. And we see that that's the same as the slope that we knew it had to become because of the negative reciprocal. In the given equation, c is a constant. The equation has no real solutions if c is greater than n. What is the least possible value of n? Well, this question is asking about the quadratic formula. The quadratic formula has variables in there a, b, and c, and they come from up on the original equation. The coefficient here in front of this is a. In the second term, it's b, and then c is the unknown. So we'll list our a, b, and c off to the right. Now for this practice problem, they're really only talking about the discriminant, and the discriminant is what's underneath the radical. So if what's underneath the radical gives you a positive number, then there are two real solutions. If it's a 0, then you have a single repeated solution. And if you have a number that is negative under the radical, well, the square root of minus 1 is equal to I, which is an imaginary number. That would mean that this quadratic would have no real solutions. So what can the smallest value of c be? Well, what we do is we pull the discriminant out and we work only with that part. So we know b is minus 34, and we know that a is 1. Then we square minus 34, which is 1156 minus, and then 4 times 1 is just 4. So 4c. Now I need to know what number c I'm allowed to put in here for this to still become a positive. So, or 0. So c times what number would give me 1156? Well, if I was to divide the 1156 by 4, I get 289. So c must be smaller than 289, because if I use a number bigger, then this entire value would become negative under the radical, and the discriminant would then be a negative number, and we can't have that. So if c is got to be less than 289, then the answer to the question, what's the least possible value of n, the answer is 289.